In this lesson, we're going to learn how to solve some rational equations. We're going to start with relatively simple ones, and then we'll go on and try one that's a little bit more difficult. We're actually going to approach rational equations with several steps. The first thing that we're going to try to do is we're going to look and see if there is any number that would restrict our domain or our x values if we were to get that as our solution. If that is the case, then we would have to eliminate that solution. In this particular problem that we have as our example, we notice that x minus 2, if that were to equal 0, that would cause a 0 to be in the denominator of the first fraction, and so we couldn't do that. And so we got to find out what that is by moving our negative 2 over. We find out that x would have to be equal to 2 to cause the first denominator to be 0. So our first domain restriction is going to be that x cannot equal 2. Also, we notice in the second fraction, x plus 1, if that's equal to 0, that would also cause an illegal function in math. That would mean that x equals negative 1 would cause that to equal 0. So x cannot be equal to negative 1. So our two domain restrictions are x cannot equal 2 and x cannot equal negative 1. As long as we don't get either of those values for our answers, then everything will be okay here, negative 1 or 2. So now, keeping that in the back of our mind, let's go ahead and solve this problem. The first thing we want to do here is find a least common denominator for this problem. In this case, we want to write down everything in the first denominator, which is x minus 2, right here, and anything in the second denominator that's not in the first. And so that would be x plus 1. So our least common denominator for this particular problem is going to be x minus 2 times x plus 1. Now, once we've found our least common denominator, what we're going to do is multiply through the whole equation by our least common denominator. So I'm going to go here, and I'm going to put x minus 2, need a little bit more space here, x minus 2 times x plus 1. And I'm going to go ahead and write that over here on the other side also, like this, so that we can see what happens. Now, notice when I multiply this side times x minus 2 and x plus 1, that the x minus 2's cancel, and that just leaves for my numerator 5 times x plus 1. On the other side, the x plus 1's cancel. That leaves 6 times x minus 2. Now the good news here is that our denominators are all gone. And so now we just have a regular equation to solve. We'll distribute the 5x plus 5 equals 6x minus 12. Distributing the 5 on the left, the 6 on the right, and now we just solve a regular linear equation. I'm going to move my x's over to the right side, and I'm going to bring my numbers to the left. So bringing 12 to the left becomes positive 12 plus 5, and taking the 5x to the right causes it to be negative 5x. 6x minus 5x is 1x, and x would be equal to 17 in this problem. So we have solved this equation and found out that x is equal to 17. Now you may have noted that had we just cross multiplied 5 times x plus 1 and 6 times x minus 2 in the original problem right here, we would have gotten the same answer. When you do cross multiplication, all you're really doing is finding a least common denominator and multiplying the whole equation through by that least common denominator. So we're going to use that same idea even when it's not just a single thing on each side that we're cross multiplying. All right, let's clear the board here. We're going to look at another example that goes with this, like this. This time we need a common denominator, but we want to first find out if there are any of those restrictions that we have. Notice here our restrictions. I'll write those down here. We don't want x minus 4. We don't want to have 4 as an answer. If we get 4 for an answer, we can't use it. And also just x. X can't be equal to 0. So as long as x isn't equal to 0 or x isn't equal to 4, whatever answer we come up with will be acceptable. So we have to keep those in mind as we determine our actual answers. No 4s and no 0s. All right, let's go up here. Now we're ready to find our least common denominator again. Write down the denominator for the first part, this first fraction. And then anything that's in the second one that's not in the first, well, there's an x. In this case, anything that's in the third, we've already used the x. So our least common denominator is x minus 4 times x. Now, again, we need to multiply through the whole equation by the common denominator, which is x minus 4 times x. Again, kind of hard to see there. I'll write that a little better. Now remember, I'm distributing x minus 4 times x to each one of these terms, this one, and this one, and this one, when I multiply, so every one will be handled by itself. So when I multiply x minus 4 times x times the 12 over x minus 4, the x minus 4's cancel here. That leaves just 12 and x. When I multiply x minus 4 times x times 3 over x, the x's cancel, leaving just 3 times x minus 4. And then finally, when I multiply x minus 4 times x times the 9 over x, the x's cancel again, leaving 9 times x minus 4. And you'll note again, the denominators are gone. They've canceled one part in each case of our least common denominator. And so we're able now just to put together the x's and the numbers and solve a linear equation. Going to distribute here. Very simply. And I have this problem. And now 12x and 3x. I'm just going to start to group so that I can simplify. And I'm going to bring my x's to the left. 15x, and when 9x comes to the left, it will become minus x. So 15x minus 9x is 6x. Negative 12 will become positive 12 on the other side. Positive 12 and negative 36 is negative 24. When I divide both sides by 6, like this, going this way now, x will equal negative 4. And remember, negative 4 was an okay answer. As long as we didn't have positive 4 or 0 for our answer, it was allowed. So we have found a solution that will work for x in this rational equation. If you want to see a little bit more complicated one, just go on to the second lesson, and we're going to look at a little bit more complex problem in the second lesson.